Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll use calculus to calculate the velocity and acceleration of objects moving in a straight line. So let's say a particle is moving in a straight line. Its position is given by this function here. We're going to calculate its velocity after 2 seconds and 5 seconds, acceleration after 2 seconds, and its average velocity in the first 3 seconds. So you won't need to do this when you're answering questions, but I'm just going to draw a rough sketch of this function here. So here is a rough sketch of this function here. As I alluded to in a previous video, it's very tempting to think that the particle is moving in this trajectory, that it's got like this curved path and then it stops, turns around and things like that. In actual fact, the particle is moving in a straight line. This function here just tells us its position. This says it starts, 10 units to begin with from a given point, and then it moves away from that given point, stops, turn around, and it moves towards that given point, and it reaches there around about 4 seconds. So what's actually happening, starting at a given point, starts 10 units away from that, and then it moves away from it, turns around, and then starts moving towards it and gets there at around about 4 seconds. But it's moving in a straight line. This just tells us about its position. So now that we've got that out of the way, let's calculate velocity and acceleration. So y is going to be its position. So y is going to be a unit in distance. So let's just say y is in centimeters for argument's sake. X will be some unit of time. So let's say x is in seconds. So y is distance, x is time. So velocity is the rate of change of distance with respect to time. The velocity is just going to be given by the derivative of this. So we have y dash is equal to 2x minus 3x squared plus 9. This is the velocity function. If I substitute a value of x into this, it will tell me the velocity of the particle. So if I substitute in x equals 2, because I said x is in seconds, then I would get y dash is equal to 1. So that means that after 2 seconds, it is traveling, the particle is moving at 1 centimeter per second. If I substitute in x equals 5, that means after 5 seconds, the velocity is actually minus 56. So that's what I got from substituting x equals 5 into here. Now you can have a negative value for velocity. All that means is it's moving 56 centimeters per second, but the minus just means in another direction. So after 5 seconds, it will have reached this point here, and it's moving away from that point in this direction. So velocity can be negative. So that's all about velocity. So what about acceleration? Well, acceleration is actually just the second derivative. Acceleration is the derivative of the velocity. It's the change in velocity with respect to time. So to get the acceleration function, I just differentiate the velocity function. So I just get 2 minus 6x. So if I want to know the acceleration after 2 seconds, all I do is substitute in x equals 2. So if I substitute x equals 2 into here, I get minus 10. So here the unit is centimeters per second squared. So what this is saying is I am changing my velocity at 10 centimeters per second every second. This negative means that the velocity is decreasing, it's going down. So after 2 seconds, the velocity is decreasing at a rate of 10 centimeters per second every second. So to find the average velocity in the first 3 seconds, I just need to find the position, which is the distance, and divide by the time. So at x equals 0, we have y equals 10. So that's saying that this particle is starting 10 centimeters away from some reference point here. So at x equals 3, if I substitute it into the original equation, I get y is equal to 19. So that means it started 10 centimeters away from this point, and after 3 seconds it went to about 19 centimeters. So it has traveled 9 centimeters in 3 seconds. So the average velocity is just 3 centimeters per second. How easy is that? Alright, thanks so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.